Right, thank you. Thank you for the invitation. Hope everyone had a good lunch. Now, hopefully I've got to try to keep you awake for the next few hours. But I am told that there are beers later on, and if all else fails, I've got an extra beer up the front here for everyone. So my name is Gunter Ollmann, Chief Security Officer for the Cloud and AI groups inside Microsoft. Yeah, Microsoft's a very big company. Basically, what the areas that I'm responsible for are looking at the next year plus of security technologies that we're going to build and apply, and it's a longer term vision for Microsoft on the security front. And so, what am I here today to talk about? Well, I thought long and hard about different sort of topics, and I thought most appropriate for the for the team here or for the group here was really about looking at how SIEM has changed. So, security incident response, incident and event management, how it's changed, and where it's going next. The reason for the change is that. Well, I think if you've been watching the news fairly recently, you would have seen an awful lot about Cloud SIEM and Cloud Native SIEM, both in particular from Microsoft with Azure Sentinel and Google with their Chronicle solutions. And so these are all cloud-based, but more importantly, AI-based. So when I started looking at doing incident response and event management a long time ago, how many of you, have begun their sort of security careers about 20 years ago, looking at things like, does anyone remember Site Protector, Internet Security Site Protector? None? Okay, well that's all right. So over the years, the technology required to analyze threats, to investigate compromises, and to perform response has changed fundamentally during that time. So 20 years ago, if you were a poor old analyst, effectively you had tree-type dialogues to start navigating and trying to find out what was a big red light and what it actually meant. That didn't really work very well, and so a couple of years later, the first generation of SIEM technologies came out, where effectively take all of those logs from all of typically your network defenses, load them onto one place, and then scroll through those logs, right? That didn't really work too well, and so if you're a good analyst, you would have just effectively, give me the command line and write scripts to investigate and hunt through your SIEM technology to find those particular threats. That was okay until the volume of data started increasing dramatically, right? And then we started to move on. So if I sort of think of my career, about 2006 to about 2012, much of the technology then switched from SIEM and command line to Hadoop clusters. So using Hadoop and NoSQL type engines to be able to group and cluster types of events together, and then start analyzing and looking for threats. And that was good, except that you had to be a bit of a data scientist, and more importantly, you probably had to have, if you've ever built Hadoop clusters and try to manage them, you probably spent about 90% of your time just trying to, manage the Hadoop cluster versus about 10% of your time actually trying to get data out of the systems. And so technology changed and moved on further. And so really today, much of the technology that you'll find for looking at security events and security logs is really graph-based technologies. So in particular, AI-based graphing and log analytics type systems. So that's been the 20-year journey. I think that the part where we are today is this thing called Cloud SIEM. And wherever you pick up the press today, you will find lots and lots of notations about this whole thing about Cloud SIEM. I want to step back a little bit on that, and that is, there is a different type of SIEM and what that actually sort of really means, right? So if you like today, there are 3 classes of SIEM, and they get called cloud in various ways. So you've got your on-premises SIEM. Okay, so effectively, this is my racked hardware. It's basically sized by the largest load I think I'm going to analyze, and it will have local SOAR connectors, so local controls and connectors for sending new commands to say Bitdefender or to your Cisco routers or firewalls. The bottleneck for that type of SIEM has always been data retention. So many of the SIEM operators took their, over the last 3 or 4 years, took their on-premises, tin wraps solutions and effectively put them onto virtual machines and then loaded them up into the cloud. Okay, so at that point you would have infrastructure as a service type hosting of SIEM with a PaaS interface, so a nice little web interface for controlling those. That's all right, you get a little bit of cloud scaling effect, normally rapid scaling across horizontally from a data structure side, but in many ways you can sort of think of that first generation or that stepping stone of generation of cloud SIEM was really sort of a managed type of service. The biggest bottleneck with that type of approach has really been the IaaS pricing. So by moving from on-premises to the cloud, you're not really making use of anything from the cloud side. You're effectively using the cloud as an external hosting provider. Cloud SIEM, in particular when it becomes cloud native, starts changing the way that we look at these things. So we move to a layered SaaS model and more often to a service-like architecture. So hyperscalable in all dimensions. Importantly, when you look at the solutions in this area, is now AI enabled and it's AI by default. And more importantly, I think when we look at the SIEMs technology as they're changing, especially now, DevOps compliant is mandatory, right? And so the DevOps cycle is now built into the cloud SIEM. The bottleneck, interesting, and I'll cover this in quite some detail, really, is the bottleneck lies in the labeling process. So what that really means is that I've got all this data, I'll always have all this data, I'm very good at hunting through the data, the machines are even better at finding things through the data. It's just that the machines find things that have no labels and requires an expert to understand and then decide on how to respond to the things that the cloud throws up. So what are some of the big trends, right? Nice, easy one I think for most people to understand when it comes to security information technologies really is this data trend of this, if you like, this hockey stick approach to data and data volume. So today, if we look at that volume of data, I sort of break it down into a number of areas. So first of all, the volume of data is increasing, doubling, tripling, every week in some instances. So what constitutes that security data? So we're talking about alerts, events, and logs. We're also engaging sort of the telemetry, right? Flows from the network devices, threat intelligence, TTPs, and detonations. Detonations, if you're not familiar with that, is effectively a lot more work has gone on taking a malicious link, malicious URL, or a suspicious file, and then opening it and in a controlled environment, watching what happens and extracting those behaviors. And so over that time, while those sort of technologies have changed and we've added more technologies to that space, the role and the use of SIEM has changed. So, if your organization originally started with a SIEM technology and you're a large organization, you probably walked up to the stage, you have a SIEM of SIEMs because an individual SIEM couldn't handle this type of data going forward. Now we're a sort of cloud native SIEM is the only really area that we can start dealing with the true huge volumes of data that we have to deal with. To give you a little look under the cover, and so this one here is the background of something like Azure Sentinel from a cloud SIEM, but it'll be the same type of approach for anyone that sort of goes cloud native. So if anything from left and right, you have the data collection, so the data logs, the custom apps, and the information that's being passed through there, right? So go through a parsing engine, and at that ingestion stage, there'll be a number of connectors, so for example, WEF, syslog, and other types of connectors. The vendors themselves of those devices will make their own connectors, there'll be network connectors, and then there'll be custom data connectors for your own organizations and your own applications that you sort of built. The next stage, if I have those connectors, is effectively normalization. So how do I convert all these different, let's say I have 3 different vendors for vulnerability scanning, right? And they all call this, they all call, I don't know, cross-site scripting vulnerability, have slightly different names and different sort of descriptions. I need to normalize those to bring them down into one description and to be able to understand and track that from a mapping perspective. If I had to look at all the areas of security and where we are today, in particular from a SIEM technology, I think that normalization phase is one of the areas that will probably, I would like to get rid of as fast as possible. The normalization phase loses a lot of data and a lot of new intelligence that way. So once we've normalized that data, we then move on to, so if you like, the storage. And so today's storage really can be broken down to 3 classes of storage. So log analytics, so effectively how do I take all those logs and store it in a searchable database. Blob storage, so all the other information that can't be stored in individual logs or individual analytics. And then a graph DB, so taking some of the metadata, some of the highlights, and being able to use that as a mapping between intelligent clusters. After that, the next area of cloud-native AI really is about how to build and train the models for detection and classification. And we'll cover that in a lot more detail. After I've got these sort of, machine learning models or AI models, then I can move on to enrichment. Okay, so that'll be taking in threat intelligence, letting analysts build up their own bookmarks and building up their own data sets and query sites and security graphing. Okay, so be able to take that threat hunting experience through graph and convert that back into a replayable playbook, for example. And then the last stage, really, serve and visualize. So the UX, which is always great fun to sort of play around with, but on the day-to-day side and from a SOC operations, really moving into the search and sort of detection type technologies. So if that's the sort of, if you like, the core chunks of SIEM technology, how do these things sort of play out? Okay, so when I look at where is the cutting edge today for SIEM, but in particular the threat hunting experience and, if you like, how these things are going to evolve, I think it's a good idea to take a snapshot of where the state of the art is today. So first of all, should be without any argument, the state of the art is cloud native. Okay, the big thing here is all the data, all the time. Okay, and it's really hard to understand or to stress how important that is and how big a change that is. So traditionally, if I was bound by the number of hard drives I had and the speed of access, then maybe I could analyze data, threat hunt, and retrospectively threat hunt through, say, 90 days, 180 days. Okay. If you've been following things like the Verizon reports, threat reports, or the IBM reports, or I don't know, you name the next 50 threat reports that sort of come out every month or every quarter or every half year, what you'll find is that probably the average time to detection of a compromise is somewhere between about 190 to 200 days. So that's the average, right? That means that your SIEM really needs to have probably about 3 years, maybe 5 years of data stored in it for you to be able to look for threats, hunt for threats, investigate threats, and draw out incident response plans against, and to manage against that. The other key piece about being cloud native, it obviously being hyperscalable, but also the cloud automation. Okay, so when I look at cloud SIEM, what I also focus my mind on is all of the workloads that are also in the clouds. Okay, and this is a new area really of, as organizations move from on-premise and have a mix of different, I think the on-premise security environment has about 170 different types, 170 classes of technology and about 70 different vendors on average. Okay. By the time you move to the clouds and running advanced workloads, you're down to about 10 to 12 vendors and about 70 technologies. But those technologies tend to be heavily weighted towards the cloud provider. As part of that package, though, the cloud provider is also providing all the automation that surrounds that. The next big piece really is visual investigation. Okay, so moving on from simple queries and entity matching to now be able to traverse between entities such as users, assets, apps, and URLs, but also now between activities. Okay, so logins, transfers, usage, all the telemetry, all the statistics about connections and workloads as they go forward. And more importantly, what we're now starting to see is the growth of new AIs that actually automate that visual integration, visual investigation process of being able to predict what you're going to be able to click on and provide the best answer going forward. The next part of cutting edge is really the use of machine learning notebooks. So the ability to be able to create your own machine learning classifiers, train your own data sets, be able to provide almost an advanced scripting approach to automated hunting going forward. But more importantly, be able to take these notebooks and be able to pass them on to other teams inside your organization, or be able to share them as playbooks externally. And while it's the third slot there, I could create many, many slides on this area, but effectively AI, right? So at the large public cloud sides, cloud service provider side, AI is pretty much everything that goes on behind the scenes here. So for example, the key things that I'm most interested from the AI side, kill chain and attack reassembly. Just want to be clear here. Does everyone, raise your hand if you don't know anything about kill chains? Raise your hand if you don't know the MITRE attack framework. Okay, a few. Unfortunately, there's only a few of you here. I'll be happy to talk about it a little bit later. But the attack framework is really where a lot of the technologies are now changing and moving to. So, upgrading from kill chain type approaches into the attack framework and attack reassembly. Also moving on to anomaly-based detection, auto-training of classifiers, so the ability to train up an AI to solve a particular class of threats or to identify a kill chain, and be able to then take that model and deploy it somewhere else and to relearn a new environment. So for example, for me to be able to create a machine learning algorithm for spotting impossible travel type scenarios for email brute forcing or email access, train that up inside the MSRC SOC, and then be able to deploy that into on-premise SIEM for other customers, and for it to relearn and to be able to start detecting that class of threat almost immediately. Give you an idea of scale and why this is important. Okay. So one of the things that, as a cloud provider, perhaps one of the most common scary attacks that I see is this particular event. So what happens is that some bad guys guess the password or the login credentials for a customer's workspace, so for their subscription. So they compromise the identity of the subscription owner. They then log in. They create a service principal, so effectively a new account for being able to manage the workloads or manage the subscription. They then add that newly created principal to the admin for that subscription, and then they start doing bad things. So extricating data, locking out systems, spinning up Bitcoin mining, all these sort of things. So that first thing, if I want to go looking for these types of things, how do I go about this? So today, using from the Azure customer's perspective, I see about 300 billion identity logins, right, per month. 4.1 billion Active Directory admin actions, and about 3.2 billion Azure admin actions. Okay, so you can imagine if you had your SIEM still on premise, I've probably filled up your SIEM already, just with the data that that's required for looking at this one class of threats. Now, as I start using user behaviors and start looking at anomalous behaviors for those detections, I can start shrinking these things down, right? So if I'm looking for, if I can start identifying behaviors, say that these actions are happening in sequence, and they were happening at a time that is, outside the normal business hours of that organization, and things like this, right? I can start shrinking that down to about 28 million, so go from billions down to millions of identity detections, 20 million anomalous Active Directory actions, and 2 million anomalous Azure actions. Now, if I'm smart, I start converting into graph-type relationships. Okay, and so the graph-type relationships, I then start applying a probabilistic kill chain model to this. Okay, and so I start bringing all that data down to effectively 320 graphs or subgraphs, which on a typical month at the moment sort of operates at about 18 cases. Okay, so if you sort of think from an analyst perspective, without that use of artificial intelligence, but more particularly the use of graph graph-type technologies, I would still be trying to sift through those 300 plus billion events to find out which ones are actually resulted in something, were about to result in something bad. Okay. So from my perspective, and as we go forward as a cloud provider, I have to approach everything from this type of scale. Okay, anything that I start looking at that requires a human to be involved in is going to be a failure from the first start, right? So I have to look at it in a different way. So what we've also had over the time is that there's been changes in the way that hunters think. Okay, so a couple of decades ago, it was all about alerts. Let's go for, we'll stack these alerts from green through to red or into brown, depending on your color scheme. And you start with the brown and work down. Okay. Then we started moving on to event correlation. So just instead of looking for individual alerts, I want to bring these alerts together as clusters and be able to say these number of alerts represent an attack pattern. Right, and that attack pattern then developed into timelines and kill chain reassembly. For the last couple of years, that's changed into the MITRE ATT&CK framework, and being able to build up the attack attribution that goes behind there. And where we are today, from a machine learning side in particular, is sort of the labeling and the training of response systems. Interesting one here really is from a threat hunter perspective. For many organizations, almost the role as a security professional, the role that many people aspire to today is the threat hunter, right? And particularly to be the best threat hunters there are inside an organization. The question I've got though is that with all of the data that's coming in into your organization, first of all, how many of you here do threat hunting of some degree? Okay, so most of the hands here. How many of you, raise your hand if you spend more of your day proactively hunting as opposed to having to just clean up and investigate stuff that someone else pointed out? Okay, 3 or 4 hands. Okay. So the interesting thing is that despite all these types of technologies that are out there and the growth of threat hunting is still largely about incident response and retroactive looking at threats, investigation of threats. Okay. What we're also finding though is that we're getting more and more data. So our ability to acquire and process data inside the cloud has resulted in customers and organizations turning on more logging, richer logging, more events, and passing more data through. And so we're into the sort of hamster wheel of more data, creating more work, providing more visibility into the threats. However, we have less time to investigate them from a human perspective. And from a human perspective, we're also getting further away from when the event actually happens, so we're doing retroactive hunting. Now, an interesting part of that really translates into, it used to be from a threat hunting perspective, it was hunting for needles in a haystack. Okay. Now with the types of systems that we have, what we eventually end up with a haystack of needles instead. More often than not, we've now moved on from a haystack of needles into haystacks, labeled haystacks of needles, right? And so we have to figure out ways to prioritize the way that we investigate going forward. And so that prioritization comes in many sort of forms. And so, a large part of today really focuses on how do we train AI systems to understand, to replicate what the human being's doing. How do we engage the human in the labeling process, but how do we actually score these types of events, and so that we can reprioritize those. Well, so what we're seeing is a lot of integration of combining internal intelligence and third-party intelligence together. And in the case of the attack framework, also the TTPs, tools, tactics, and processes of the bad guys, for being able to provide attribution. But those haystacks themselves keep on growing. Okay, and so despite, for many organizations, they may break their threat hunting teams into malware teams, APT teams, and other specialized threats, those haystacks just keep on growing. So, so for many organizations, what we're finding is that they're still swamped no matter how many more people that come on. What we also find is that the more security technologies that are deployed, the more haystacks we end up creating, or needle stacks, should we say. So that sort of moves really onto cloud-native threat hunting. Okay, so we have to relook at all the tooling and all the processes that we've used in the past and not only reinvent them, but fundamentally change the way we do these things. So first of all the data, all the time. Okay. So that means that the volume of data is no longer a bottleneck. So retention period is important. Ideally, as a threat hunter, you want to get as much of that data and store it for as long as possible. However, if you ask your CFO or your chief legal officer, they'll probably say no more than 7 years or no more than 3 years because of the legal constraints that are on these things. What also means that you can hunt across larger periods of time with new TI. Okay, so if you've got 7 years, you may get the latest batch of threat intelligence from a Verizon report or whatever, and you can go back through those 7 years and find out when you were may have been potentially compromised through that. The other part is actually learning from every single successful hunt. So from the good guys side, as you find and sift through this type of data, finding these particular threats, being able to describe that threat and labeling it, the machine then learns from that, and so that you don't need to repeat that process going forward. Okay, and of course to assemble and correlate all that data together. So what do these things sort of look like? Here's just a snapshot of Azure Sentinel from 2 weeks ago before I was traveling here. What you see is a different sort of approach from a threat analyst perspective. So here what I've just grabbed is the different way of looking at the hunting procedure. So you sort of see in this top right-hand corner, the MITRE attack framework. So being able to take, instead of having a look at an entire kill chain and try to piece together a kill chain from a graphical perspective, start breaking that down to individual components. So for example, long DNS URI queries, for example, which is part of, which is associated with a number of TTPs for bad actors, and start managing and hunting on that in that aspect. More importantly, what you sort of see is this stage of providing the attack framework, the ability to search and hunt on these individual things or collectively, and the ability to modify, create your own queries, and then build compound queries going forward. If that's one way of sort of viewing how other technologies are sort of changing, I think the next part really is understanding what the clouds and cloud AI actually brings to the table from a security experience. So here, made up some graph. Here's if you like, a two-dimensional layout of all the different threats and alerts over time that are happening inside your organization. In traditional way, what would happen is that we would look at these particular events, build up a timeline, and call that attack timeline, and this would be perhaps our kill chain that we'd be studying. How we got there was in one of two ways, right? At some point, something was flashing loud enough, red enough, flashing the most, or law enforcement knocked on the door and said, is this your set of data? You associate that with one particular event, and you start mapping everything that was associated with the event back in time to eventually get to the start, and so let's say the start was a little bit of brute forcing, for example, right? The other way is that I have all this data, and I'm now given a little piece of threat intelligence of a, let's say, of a command and control server. And I look through my logs and I find that that command and control server was used at this particular time, and I start building my kill chain in both directions. Okay. When I look at the combination of cloud and AI, I work the other direction, and that is I start from the very first events, and I start, with every one of those events that I see, I start mapping up probabilities that this event is going to go and is going to be connected to another event, and whether that probability of that second event is going to lead to a type of threat, a type of TTP, or an aspect of maliciousness. And so what happens that over time, as I see these events cascading, I'm able to alert and provide insights saying that, I'm starting to build up a kill chain, but I've arrived in an earlier description of that this is heading towards something bad. Okay. So while that's happening, the other parts that are fundamentally changing is the way that user and event behavioral analytics is coming into play. So today, much of the on-premise UEBA type technologies are focused on the network layer, right? Or with inside, say the desktop protection suites installed on the actual host. Okay. So what's happening there is that I'm looking in real time at the raw data and I am creating new UEBA alerts on the fly from that. When I'm looking at it from the SIEM perspective, I'm working in a different way, right? From the SIEM perspective, you've got to assume that I don't have, the SIEM doesn't have presence on the endpoint, it doesn't have presence at the network. Instead, it's reliant on all those other security technologies that are already there that are creating new alerts, new events, new incidents, or just raw telemetry. So the traditional way from a UEBA perspective was, assume the attacker only takes one path to obtain their goal. It assumes the attacker follows a static kill chain and that the attack path is fully executed. And also assumes that the information is present in all the logs. Okay. That breaks most of the time. Right, and so from a cloud SIEM perspective, I'm applying AI, we do it a different way. So first of all, iterative attack simulation. So as I receive new logs, new events, I'm trying to predict where it's actually going to go, and I'm going to assign probabilities for these predictions. And so I'm going to fuse these different events that I'm seeing and collating, and be able to map those against certain scenarios, attack simulations that I care about the most in the organization. What I'm also doing is I'm going to provide a probabilistic kill chain, right? So as these events are happening and these fusion of the different events are coming together, I'm going to try to predict which way this event is actually going and what's servers and what's the risk and priority and also the overall impact of organization as it goes forward. And then also using advances in graphical methods, I'm also basically putting in random stuff into those predictions just in case I might have missed an event or a class of technology wasn't deployed or something happened so that I'm going to assume that I'm going to miss out certain types of data and so I can project in advance going forward. Okay. What else is happening in this space? I think one of the newer interesting areas is AI-powered threat intelligence, in particular forecasting. So I started, before I got into security, my background is in atmospheric physics and meteorology, if you like, the first bigger uses of supercomputing before everyone got into the nuclear trade, shall we say. But the forecasting is an important part. And so where we are now seeing, what we're now seeing the first generation of AI based threat intelligence systems, commercial threat intelligence systems. So for example, being able to take all that cloud information, the last 30 years of internet traffic, domain use, domain abuse, malware analytics, bring them all together and then be able to fuse and project where these things are going. So for example, one company based in San Diego, Seclyptics, provides an average of 51 days in advance notification that an IP or domain name is going to be used for badness and what that badness is going to be with, I think it's maybe 97% probability. Right. Other ones like Notice Technologies are really looking at the threat actor, and so as the threat actor, you choose your list of threat actor that you care about, and you're notified in real time, what new infrastructure the bad guys have set up, but it also provides, prediction of what that infrastructure is probably going to be used for and what campaigns it's going to be used for today. So these are cool types of technologies, but if you sort of think of how would I apply these from my existing type of security technologies, and this is where it gets interesting of being able to apply prediction systems into Cloud SIEM so that you can pull in, you can watch the internet as a whole as a cloud provider and then predict how those changes that you're observing in the cloud are going to affect and potentially result in attacks against your customers and against their workloads. So from a threat hunting perspective, we mapped out those particular events in a bit of a kill chain. What we can also do is, as you're using graph technologies, you can build out all those other associations. So while if I was looking through events, I was just tracking back from from the the most evil, back to the original start. There are an awful lot of other activities that the bad guys were doing at the same time, right? And the types of tools, the types of systems they touched, and things like that. This becomes a mix of TTPs, and provides a little bit of a fingerprint for either a bad guy operator, a type of tool that they're using for automation, or a class of attacks. And so effectively by combining those together, if I see these types of shapes in the data, I can start building and training classifiers for this. Right. So all this today you can do yourself, or just part of a cloud SIEM. You just sort of say, here are these 3 attacks. I think they're all roughly the same. Click a button, go build a classifier, check that classifier against your data and see if you've seen other threats that are very much like this, right? And label that classifier. That's great for a retroactive hunting perspective. Parts that are much more interested though are how do I get ahead of the threats and start proactive hunting for these things. And so if I was to look at that type of shape, that cluster, that machine learning instance, where along this process am I comfortable with the probability that it's going to lead to badness, right? Completely artificial, made up in here, right? At some point, could I say I'm 98%, am I 75%, 20%? At what point am I comfortable with this? And so what's happening, and this is why the MITRE attack framework is so important, if I can take these smaller chunks here, these TTPs or phases of an attack, I can raise my confidence of being able to detect these things, but I can also overlay those with a framework of the threats that I really care about, these bigger trained and labeled threats. And I can start doing things a little bit differently. In particular, I think one of the biggest things one of the newest things from attack mitigation for the cloud, it really has now become conditional access controls. So what conditional access controls allow me to do is that it is now possible for the systems for the cloud to identify who the user is, who the victim is, who the attacker is, and where in the attack process they actually are. So for example, Microsoft's cloud knows that Gunter Ollmann is currently logged in here. My cell phone, when I last authenticated, was here, roughly the same location. I used a PIN number on Windows Hello to open this machine, so for example. And because I have PowerPoint open and connected to the internet, probably the last time I made a change to the PowerPoint was automatically backed up. So it already knows all this types of information already. Now the bad guys, let's say that someone over in Singapore has, successful brute force, after tried 5 times against the Gunter Ollmann account with a password, and the 6th time they were successful. Okay. So first of all, the cloud knows that is a different instance of Gunter Ollmann here than it is over there in the first part, right? Through the machine learning side, it could also say, well, actually, I did see this brute forcing, which I think is suspicious, and the probability that this could be the start of a ransomware attack is 16%, for example. So because it's so high, then what I will do as a conditional access is, tell you what, I will just turn Gunter's permissions on these servers to be read-only. Okay. And at the same time, maybe it's not Gunter, or maybe it is Gunter, and so they use the password, and so I'm going to ask for a different biometric for that particular instance, right? And while that biometric is being calculated, so for example, prompt the MFA, I will also disable admin permissions sort of going on. And so what happens is that the systems are able to uniquely identify but take actions against the bad guys without interrupting me while I'm doing this, okay? Traditionally what would happen is that, a detection of that my account had been brute forced and compromised, which would then happen that the result would be my account would be locked out. My machine would then prompt me up here saying that I've now been locked out, close all the applications and change my password. So the ability to separate these functions is highly important going forward without interrupting users and also for mitigating the threat before it actually evolves into something bad. So cloud effects, there are a number of key things is that, if I sort of step back here, if you imagine that you're running your organization, you have your workloads in the cloud, you see this amount of the cloud. From a cloud operator's perspective, I see across all those clouds, right? Not looking into your data, but looking at all the events that happen around those data and that. So for example, I can tell you and tell the entire cloud when a certain IP address that has never ever touched the Azure cloud and has never or may never have touched port 22 now suddenly starts doing that. I know that, and then I can apply that knowledge across the entire organization, right? And so I can start labeling and say, this is such anomalous behavior, then perhaps you want to be a little bit careful about this. And so I can also, those models for detecting threats inside your organization, I can take those models and apply to larger data sets, refine those, and can spot different classes of threats and learn against those threats, and then create smaller models that can be deployed inside your own organizations. What all also means is the other way around, and that is, let's say somewhere else in the cloud, a new attack is detected, it affects someone else. I can see, in this example, there's a watering hole, and there's attack command and control. And from that, I can deduce the threat intelligence, or TI, and the TTPs. And so from the cloud's perspective is that if a threat is successful or a type of compromise that gets labeled from anywhere inside the cloud, I can then apply that knowledge preemptively to everywhere else inside the clouds. Okay. And so the bigger the cloud becomes, the faster the rest of the cloud becomes immune to these attacks. Now, if I'm operating that side, unfortunately, one of the key things is I end up ditching a lot of human constraints. Okay. So I need to start thinking about, these logs and things that are human readable. Do they need to be human readable? In fact, one of the biggest constraints that I have today is RFC 5224, basically syslog. Okay. Here is something that is over 20 years old and defined for allowing humans to read what the machines are, basically spewing out. I also need to move to real-time, not quote real-time or real-time TM type responses, right? So I need to be able to respond, observe these events as fast as possible, and take actions as these events are being collated. And also need to propose mitigations and responses to those threats. So what does that mean from a threat hunter perspective? Okay, so today if I look at a typical threat hunter role, starting from the bottom, tier 1, tier 2, tier 3, so effectively tier 1, false positives, false positive removal, type of things. Tier 2, there's a script for that, there is a procedure, there is a methodology for that, go deal with it. And tier 3, basically anything that skips those two paces, right? Bit of proactive threat hunting, incident response, being a bit of a security architect, also a risk commentator. From a cloud perspective, today, if you're in the cloud, what's the role of the threat hunter? Effectively, tier 3 analyst, bit of proactive hunting. The role of the security architect has become much more important. The risk commentator, so instead of being able to say, the sky's falling, this vulnerability you should be scared about, to now be able to say, that vulnerability is there, but here are the things I can do to protect against this and train the machine to remediate that. You also need to become be a bit of a data scientist, and you also have picked up quite a large role of becoming a machine learning trainer. Where this is really going, if I had to lay bets on the next 3 to 5 years, then I think that threat hunting role becomes quite different again. I think the proactive hunting goes away, mainly because the machines, you have to operate at real time, and so the proactive hunting becomes entirely machine-based. What I also sort of see is that security architect becoming a cloud security architect, and the data scientist piece is only a temporary part of time because we're still evolving those types of technologies, and I think data scientist role goes away as part of the security remit. And moving on from an ML trainer to AI trainer. And so the two big things that I pull out. So one is, how these roles are changing, and that is from a, Chicken Little, the sky is falling type of commentary to being able to be that business risk expert. And what that means is that as an organization moves to the cloud, all of that infrastructure, the pen testing, the red teaming, all of that managing clusters, managing containers, managing serverless types functions and that, you don't need to do anymore because it's the responsibility of the cloud provider. But what it means is that the biggest weakness in anything you push to the cloud will be the code that you push as an organization. And so it becomes more important about understanding what the business logic is and be able to protect that. And what I also see is that, what today is, 60+% of most threat hunters' role effectively disappearing down to just the tier 3 type analyst type of role. Okay. So we're running up on time here, and I'm thinking a few interesting pictures here, just see if everyone's awake. What do you think ties all of these pictures together? If you're sort of thinking of technology. Transportation? Yes, a little bit more precise. Sorry? Roads? A little bit, true, but what brings all of these things together, how we've designed our latest cars, our trains, buses, roads, infrastructure, is that everything's down, even the containers that we ship things down is designed by the width of 2 horses' asses. Okay. So 4,500 years of evolution of transport is down to the width of 2 horses. Okay. And so when I think of what AI and how we're applying AI to security today, I want to try rethinking this. So today, we talk about supervised and unsupervised learning a large part, right? So we're aligned on the human, and so we have our aspects of how we've traditionally approached these types of roles before. We've also had the same data sets. I mentioned about syslog. So these are things that were designed to be human readable. Okay. What if I move away from these things that are human readable, let the machines actually enrich the data in ways that we humans can't no longer deal with? Right. And what about when I start focusing on faster? Do I want to build a faster, better human to solve these types of problems, or do I solve it a different way? Okay. And so it sort of brings up the sort of question about what am I trying to do? Am I trying to build this superhuman AI threat hunter? Or am I trying to solve the individual pieces to that? So if you like the first robot citizen versus the Roomba or the lawnmower or the driverless cars and things like that. Although I did sort of see this fully automated lawnmower, and I didn't see any stickers about it being pet friendly. So. Yeah, and from my perspective, when I look at the cloud and that, and where we are today, I much prefer to go down the second route of getting the machine to specialize and solve these particular problems at this point in time. But it also means if I change the medium, if I change the way that I look at this particular problem, I can then start changing the way that I handle the threats. So if I moved away from, since I moved to air travel or to sea travel, I'm no longer bound by the roads or that, the width of 2 horses. And so if I start changing the medium, start looking at different ways of approaching AI and different ways of approaching data storage within a cloud, then perhaps I'm going to open up new ways of thinking about and solving these problems going forward. So the evolution of machine learning, I think, is a key part here, and that is what I'm guessing is, as the cloud has become more centralized and has more data in it, what we're also seeing is the growth of the intelligent edge. Okay, so what we're seeing there is that we require more compute to also happen on the edge points of the cloud and also the edge points of those touching of those technologies. And so I think what we're at the cusp of doing today is moving away in parallel of, instead of having just the AI central and saying, bring me all the data in one place and I'm going to analyze it, a little bit of a superhuman type aspect, is that I need to also have AI systems that are on the very edge of my network, or on the very edge of the cloud, to make those first pass decisions. Right. And one way of sort of thinking of this is, as data volumes increase, as speed of connections increase, as the speed of the threat comes, I've got to battle, as Microsoft, I'm already battling machine learning and AI-powered attack systems are against me already. So I have to operate at those sort of speeds, if not faster. Right. And so I start sort of thinking about, if you like, from a military side, I want those smart lieutenants at the edge facing the raw part of the battle, dealing with the attacks as they come in, making those decisions. But I also want to grow and groom those generals from an AI perspective, essentially taking up the next 4 or 5 steps in advance of how I'm going to not only mitigate this particular threat, but how am I going to remove the attacker from the system or from the internet at the same time. So as I wrap up, things to and ah over beverages with friends or beers tonight, I think from 8 o'clock tonight, I think it was, for beers tonight. So speed of response. The human is the bottleneck. You know, if you're doing things in the cloud and thinking about cloud security and all that, and you rely on humans, and humans are part of that process, step back, look at other ways of approaching this. So threat hunting will change, but for the better. All the data all the time from everywhere. So the machines do this thing a lot better than we can, right? At this stage, they're still learning from us. We're still training these types of systems, but even then, they're given the data volumes and the types of things they can find. It's clear that the machines are winning in this space on our behalf. Okay, so what used to be, the nemesis for a threat hunter or a security person was those rare edge events, those anomalies. Machine learning systems excel at finding anomalies. That's the easiest thing they can possibly find those anomalies. The hard part is, getting those anomalies labeled and described and then classified as some type of risk. And as we progress this part, conditional response systems, so being able to use threat prediction, being able to use AI to map activities as they're occurring, and then to take small steps injected intelligently into those processes to deflect or mitigate a threat without compromising the current user or the environment that needs to run and keep on running the business systems going forward. And the last part is, if you set your goal to be a threat analyst today, this is not saying that, in 2 years' time, 3 years' time, you're going to be out of a job. What's really happening, though, from a cloud perspective, and for organizations that move to the cloud, that threat analyst, that threat hunting role is turning into a business security analyst role, right? And so the role is becoming, in both one space, both more technical in understanding the class of threats and how the operators, the bad guys operate, but also becoming much more in tune about precisely what those threats mean and impact as your organization as a whole, and being able to do that translation from what is a threat and what an AI classes as a threat and to mitigate into business systems. So with that, I realize that I've been talking for quite some time, so I'd like to open the floor to let you guys talk, and maybe there's any sort of questions out there. Have I stunned everyone to silence, or is everyone in like a lunch coma? Sure, question in the front here.
Your threat hunting notebooks, those are Jupyter notebooks, I assume?
Yes, so the question was, do we share the threat hunting notebooks, Jupyter notebooks and things like that? So yes, you may have seen at the beginning of this year a small acquisition that Microsoft did called GitHub, and as part of that, so we've made all of the Azure Sentinel type of threat hunting notebooks, all the machine learning, Jupyter notebooks and things like that are all available there, and we're trying to build up that community. I think there are, last I heard, was about 8,000 different notebooks for different classes of threats there today. Any other questions? Going once, going twice. Okay, down the back there.
Do you see a big risk on poisoning training models, the training AI?
Yeah, so the question, do I see a big risk in poisoning of data behind sort of the models? Yes, for some types of things. So for machine learning, and supervised, unsupervised learning, and some data lake type problems, yes. That said, though, I'm approaching it from two different ways. So one is, if you're a data scientist, the threat hunting part of, if you're a security person, then threat hunting, being a threat hunter is the apex, if you like, of your career in many ways. For a data scientist, your apex today is to be a adversarial AI, analyst type of thing. And so we're spending a lot on and figuring out new ways of how to poison our own systems, and to figure out how new ways that these attacks can sort of mitigate how these types of attacks can go. But we are the this is a little bit different is that many of the techniques that are being used today that you'll see published, like a stop sign and someone puts a few pieces of tape on and it becomes a rhinoceros or whatever, or turtle or something like that. Those are, traditionally have been things like cognitive AI type systems and things like that. And so we're looking at different approaches and stuff. You use multiple classes of models together. And AI systems, and then really look at how those things work together as opposed to solving for each one individually. So that's one aspect. The other aspect is we're also looking at new ways of, if I train a new model, whether it's a Jupyter notebook or some other deliverable, can I reverse engineer that model to be able to figure out what the raw data was and sort of work back from that, right? Depending on how that was generated, things are changing very fast. What we've also found, it was an interesting one, so I was advised by the Microsoft lawyers and a few other places, was that today if you want to protect your classifier, your intellectual property inside from a machine learning side, the traditional way is to use patents. So unfortunately for the US Patent Office has said that you can only patent, so your patent has to list the inventor. The inventor has to be human. So if an AI invents something, you can't actually use patent law to protect it, apparently, so far today. So there's a lot going on in the adversarial AI side. Today, our primary approaches from a security perspective are we're using multiple different classes of models and breaking those models into smaller chunks and then really looking at conditional access as a control for actually mitigating the threat in real time. Cool. Still got 2 minutes. Any last questions? If that's it, then thank you very much for your time. Cheers.